Hi, and welcome back to the Low-Level Devil channel's Linux Distribution from Scratch series. In the previous videos we started the simple package manager code. In this video we're going to add the package building portion of the package manager. So let's get started. Okay, to start with, we're going to replace this package build. So there's the package install. Package install and package build are not complete yet, so we're going to start by working on this package build. And if you remember, in the repository section, we have a repository for each package, which has a build file, the pck YAML file. So the build file is just a script essentially. And then we also have a optional install section, which would be run after they run the install portion. But we won't get into the install in this section, but we'll focus on the build. So the first thing we're going to do is go to our SPKM folder, and we'll create a new file here. I could put it in shared, but I think I'm going to put it in the SPKM folder. Yeah, I'll put it there. So let's see. Actually, just up here, click, and I'll call it build.c. Alright, I'm going to start by just pasting in a bunch of includes. And the very first function we're going to create is just a utility function that's going to be used later in the process. This utility function is going to find the source directory after we extract the tar file. So once we extract the tar file, we're going to need to look in that folder where we extracted it to and look for a subfolder where the actual sources are. Something like 99% of these packages will actually extract to a subfolder. So you just want to find that folder by using this open-dir API. And we're just going to loop through each of the directory entries. So we'll just do this in a while loop, read dir. And so we essentially want to look for something that's not the dot or dot dot. So if the very first character is dot, we're just going to ignore it. Or if the string is, so if the directory name is pckdir, that's the package directory that we have for our temporary install location. So if it's either of those, then we're not interested in it. If it's not, then it must be the source path. So I'm going to use malloc here. I'm going to create it the length of the build base plus the length of that directory name. There's going to be a slash between them, so I'm going to say +2. Alright, so now I'll use sprintf and just build the string out of those two strings. Okay, name. Okay. And that will give us the source path, and then we'll just break at that point, because there really should only be one directory. If there's more than that, it's something went wrong. And of course you want to close the directory at the end. And since we malloc, we're going to want to remember to free that after we're done using that. So now I'm pasting in some constants that I'm going to use. This is the base build location for building a package. We have the .build for the build file, a build log, install directory, and install script. Rather than just use these all over the place independently, I'm just creating some static constants here to make it easier to change if we want to change it. Alright, and now moving on, we're going to create, and the next function is going to be our actual package build, and that takes the root and then the LLDOS package structure. So the very first thing, let's resize this so we have more room. So if we have the no package flag set, that means we don't build anything for this and we don't create a package. So we're just going to return true. That'll be the case for like groups or things like that. So now let's create a package path. And this one I'm just going to be lazy and just use a 1K char buffer. Just to show you there's different ways of doing this. You can use malloc and free and all that, or you can just create these buffers if you know they're going to be of a certain size. Alright, so now we're going to create the path for the actual package file. So it's going to be package name dash package version dash LLDOS dash 1.0.0 TXZ. So that's going to be the format for our package names, the packages that we're actually building. Alright, so let's see. Now we want to see if that file already exists, because maybe we've actually already built it. If it does already exist, for now I think what we're going to say is just not rebuilding it, already exists, and delete to rebuild. Because maybe we'll want to, run this and it'll try to rebuild it, but if we don't want to rebuild, then we can just have them remove that. And I'm just going to put a 2-second sleep just so you can see that message easier. And we'll say building package, and we'll say the name and the version. And I'll just sleep for 2 seconds as well. You don't need this, the sleeps in there. This is just to make it easier to see with all the text flying by. So now a couple of character pointers we're going to create: the source file name and the download file name. So to start with, if the package has a source set, because remember some of them might not actually have source, then what we're going to do is grab the base name, and we'll say the download file name is going to be cache file root the source, and the cache file we'll get to later. So if not DL file name, that means for some reason cache file failed, then we're going to return false. And so let's go ahead and implement this cache file before we get too much farther. Cache file. Okay, so it's going to take the root and then the file name that we want to cache, the file that we want to cache, which we're going to grab the base name for the actual file name, and then the download file name we're going to use malloc again, strlength root plus strlength dl cache, which is a constant, which I don't think is set yet, plus strlen file name plus 1 for the null terminator. Let's go ahead and add this dl cache. I'm going to put that in our package.h. So DL cache and a build path. Okay, so when we download, it's going to download to this DL cache folder for us. And let's see. Alright, so now we'll use sprintf and just build that DL file name. Again, you can do some error checking here. For instance, malloc may fail, which means you're out of memory. For this example, again, I'm not focusing on how to code everything in the best possible way. This is just kind of to show you the process of how you do this sort of thing. So I'm gonna have to leave it up to you to do all of your proper error checking, or these videos are just gonna balloon in size. So let's see, we'll check to see if it's already downloaded. If it's already downloaded, we'll just return it because it's cached. So otherwise we're going to say if not download file. So if the download file fails, we'll print to std error, failed to download. And we'll put the file name in there. File. Let's free that DL file name. And return null. And return the file name. Now this download file function we will get to. That is actually one that we did in another video. I'll leave a link to it in the description, and I'll see if I can link it on the video as well. So just to go over it real quick, it uses curl. Just to give a brief update on it if you've seen it before. It uses the curl API. Here's a little main function you can uncomment if you want to test it out. But essentially it just takes in a URL and a file name, and it'll download the URL to that file. So it uses libcurl, which you'll need installed in order to use this. Okay, so let's see, after we have cached, so now we have our DL file name. So the next step, we're going to create our build base equals malloc, and this is going to be the sterling of the root plus the sterling of the build base plus sterling of the PCK name plus 1 for the null terminator. And again, use an sprintf here to build that out. Build base and PCK name. And I'm going to have to actually do this exact same pattern for several different files. So I think what I'm going to do is just paste them. So we'll do this package base one. It's pretty much exactly the same, but we're using packaged here instead of build base. We're doing +2 because we have a slash in the middle there. Okay, so now on the next one, so now we have our, we're adding our source files, path, our build install, and our package install. So these are all just the different directories that we need to have a variable for that we can use, and we're using malloc to allocate them and sprintf to set them up. And you should know how to use things like malloc. Those are pretty basic. If you have any questions about how and why these are done, feel free to ask in the comments, or better yet, go to the Discord server. A lot of good conversations going on there. Alright, so now moving on, once we have those paths, what I'm going to do is just paste in a macro here called cleanup, where I'm going to free each of these things: the build base, the package base, source files, build install, package install, and I think we want DL file name in there as well. Yeah, free DL file name. Now I could use goto, like you'll see that a lot in the Linux kernel for the cleanup process. They'll just go to a cleanup section. Just to avoid all the negative comments I'm sure I'll get for using that method, I'm just going to use a macro here and reuse that in the different places. So we'll start by having a Boolean failure set to false by default. So if that build base already exists, that means we'd already created it and there must have been something going on in that directory. We're just going to consider that a failure because we don't want to start with an unclean directory. So what we're going to do is just print out an error, set our failure flag. And then otherwise, so what if you run it and you see that error, just delete the directory and run it again, essentially. So otherwise we are going to say failure or equals make dir, because we want to create that directory, build base with 0775 is not equal 0. So if that fails, we'll set the failure flag for that as well. So now we're also going to make the directory under there pck base. Okay. And if that fails, just another message. Failure equals true. Okay, so that's setting up the initial directories. Yeah, also if that does succeed, then what we want to do is copy the directory contents. So copy the directory contents of the repo path into our build base. And if that fails, again, we'll have a printing out an error in that case. Copy dir contents, you may or may not be familiar with. I went over it in another video. I'll discuss that briefly as well, and I'll link the video that one covers. So now we want to say if there's a failure, we want to do cleanup. And we'll return false. Okay. Alright, yep. So that copied, created the build folders and copied the contents over from the repository. And now we want to check for this build install folder. Is there a .install folder? Essentially, is there a .install folder in our build? If there is, we want to move that to our package dir, because we're going to want that to be executed during the installation process later on. We're going to use this exec command move 0, and then the parameters to the move are the build install and the package install. And 0 is the terminating. And again, exec command is another one of those functions I did another video on, and I'll link that as well. So printf, fprintf failed to move install folder, and clean up, and return false. So now another command we want to execute is the tar, and we want to essentially we're going to untar the source. So tar-xhf, the download file name. Now most of the files will be tar files. There could be some zips in the future. In that case, we'll deal with those when they come along. So, but for now, what we're going to do is just extract that tar file to our build base. If it fails, failed to untar, clean up, return false, and we need to put std error there. Yeah, let me just go to this exec command. There's an exec command .c here. And you see it takes an exe, it takes a log file, which can be null, and then a bunch of parameters, which would be the parameters to the executable, which end with a 0. So you have to put a 0 when you're done with your parameters. And again, I have another video, I'll link it here, another video that covers this in detail, so I won't go into too much detail for this, but you have all the different char arguments you can pass to it. It's a good utility function for being able to execute a process with parameters and log the results if you want to. In our case, in this one, we're passing 0 for the log call because we don't want to log the tar command results. Alright, so once we have extracted the source, now if you remember, actually first of all we're gonna go through all the extras and download these. So if there are any extras that need to be downloaded, let's do a loop through those. So for each of these, I should really create a macro for each of a stir list. That'd be a good exercise for you guys, maybe show in the Discord channel what you came up with for a macro to loop through each. So the first thing I'm going to do inside here is see, does it start with HTTP colon or HTTPS colon? If so, then we're going to want to download it. So in this thing, otherwise we're going to skip them. So if it doesn't start with those, then we're going to want to skip it. Now if it does, then we're going to grab the file name from the cache file and passing in the lstir. And if that failed for some reason, you know the drill. Clean up and return false. Alright, so now, and of course we want to make sure we continue our list, but let's see if the file exists too. OK. So yeah, we want to make sure the file actually exists. If so, we'll say extra file is allocate that for the build base plus the base name of that file name plus 2. So this gives us the full path to that file. And sprintf to build that. Okay, then we're going to use this copy file. Copied equals copy file. So we're going to copy that downloaded file name into our build directory file name. So we're essentially copying it over there. And then we want to free that thing we just allocated. We might as well free that extra file name as well. Yeah. Alright, so now that copy file is another one that I did in a separate video on, which I'll link as well. But first, let's check that copied status. So if that failed, we can clean up and return false. And let's see, before I forget, we want to do L equals L next. That's why it'd be good to have a macro for that. So let's take a look at that copy file. It's in copy.c. There's copy dir contents, which copies one directory to another, and then copy file, which copies from one file to another file. Just utility functions, and I did a separate video on how those work and all the details, which I'll link as well. Alright, so now that we've downloaded the extras, we've downloaded the source, we've extracted them, we've downloaded the extra files, and copied the extra files into our build directory. So now I want to create a build data structure. Let's see, no, this isn't where I want to create it. I'll put it up here. Yeah, right down here. So we'll do a typedef struct, which is going to contain the package. We may add to it later, but for now it's just going to contain the package. This is going to be our build data that we pass to our build process, because when we build, we want to actually build inside of a change root environment. So let me set that data here, and pck, which we get from this passed in value up here. PCK. So now what we're going to do is pass that into a function. So we want to call run with chroot, change root, however you want to say it. So which we pass in the root that we want to change to, the function we want to execute in a change root environment, and a data associated with it. The data being that build data we created. So let me show the code for this run. Alright, so run with chroot. It's going to take in the root. Again, like I said, that's the root that we want to set it to. The function to invoke in that environment, and the data that we pass to it as that void pointer gets passed straight into that function. So what we do to do this is we're going to fork a process, fork a new process. If we're in that new process, we're going to change directory to root. So if PID is 0, then we're in the new process. Change directory to root, and then change root to root. And of course, if that fails, print out some error messages. Then we're going to call exit with the return value of calling our function, passing in the parameter that was given to the function. Hopefully that makes sense to you. If it doesn't, join the Discord and we can discuss in more depth. And then after that, we're inside the parent process. So what we want to do is call wait PID on that PID, grabbing the stats, and we can say exit failure if that fails for some reason. Otherwise, we exit the status. Print dir is just a function for testing it. If you want to, yeah, I should probably comment that out, but it's fine. So if you want to test it, there's a little print directory that'll and a main function you can test it with. So going back to here, we need to actually implement that perform build, but first let's just handle the return value. So if there's a failure in the return, we'll do our std_error, our cleanup, and our return false. And otherwise we go to our build complete and we say we're packaging it. So once the build is complete, we want to execute the tar command again, this time to actually create our package. We're not going to log that either, but now we're going to pass in -c J pf, the package path, -C, the package base, and dot, and then 0 to terminate it. So if that fails, we can just say, there was an print out and there was an error creating the package. Again, clean up and return false. Okay, and at this point, we could say that we're successfully packaged our build. So package is complete. And we'll do our legitimate cleanup. First, we want to remove our build path as well. Remove directory of the build base. We can say we removed it. We should probably make that verbose. It's not a big deal though. Alright, run our cleanup legitimately and then return true. So now let's do this perform build. This will actually not be too complicated. Put it right up here. And perform build. Void p. You remember the field that we passed to it is a build data. Alright, so now inside of our perform build, remember this is going to run in our change root environment, because when we do a build, we don't want it to be dependent on anything on the host system. We want it only to be dependent on whatever is in our build environment. That's why we're using the change root, in case you didn't understand that piece. I'm just going to paste in a bunch of stuff here. These are all this malloc creating these strings. So it's where this is actually running in another process since we did the fork. So we're just going to create these little variables here for our build file, our build log, our package base, and our build base. Now we're going to use setEnv. We're going to set this variable p to the package base. And you might remember that p, seeing that p before. If you look at our repository, say in build, look down here, we have make_dir, we have $p, user liblocal. We'll do our make dest_dir equals $p. That's where that $p comes from. We're actually setting it to our package base so that when we run our build script, that p will be set. And then we can free that because we're done with it at that point. Now the char mf is our make flags. And I'm going to use -j, %d, and get nprox is a function we can use call to get the number of processors. Typically they say set it to 1.5 times the number of processors. I'm just going to say the number of processors. So now I'm going to call make flags, setting env for make flags to that value. I believe I discussed that before. They do cover it in the Linux from scratch stuff as well. So now we want to change to our build base. And now remember that find source path that we created at the very beginning. We want to find that source path, and if we find it, we want to change directory into it as well. We're actually done with build base. I'll just free that. So if source base was found, then we'll change directory to it, and we'll just print off we're changing to source path %s. And we'll free that source base. Now we're going to actually execute the bash command, not base, bash. And this one we actually do want to log, so I'm going to put the build log as our next parameter. And we want to use -e, that'll cause the script to fail as soon as anything inside of it fails, and then the build file. Then we can free that build log, free the build file, and return R, which is the result of running our .build file. And I think that's everything we need to run it now. Let's make sure nothing else needs to be added there. Actually, our package build function, we're going to want to replace that. Remove directory. Oh, I didn't cover remove directory yet, did I? There's also a bunch of warnings. Maybe I'll just clean those up while I'm in the process of fixing this one. This is just headers weren't added. Okay. So let me I'm just going to put these in the comma.h. You may want to create a separate header or something if you want to for some of these shared functions. Some of the ones that are more specific maybe. But for now I'm just going to put them all in comma.h. Alright, and let's see. Run chroot, I should probably put there as well. And that'll go in. Actually, I can put that right in the build. Not everything has to go in a header file. This one I'm just going to declare up here because that's really the only place I'm probably using it. Okay, so now in common, this is where I want to implement that remove directory function. see, I think these will be enough for the includes fcntl.h. Let me see, where is remove directory called? It's in our build.h. So yeah, I'll put it here in the common then. Okay, so this is going to be int remove directory, takes in a path to remove, and it's just going to return nftw, given the path, given a callback function to do the actual remove, and 64 as that value, and the ftw depth or ftw physical. I'm going to replace these here. So if you want to take a look at these includes, there's a couple that were added. You need to add this x open source 500 if you want to, before you include stdlib, in order to use this nftw correctly. So let me just implement that callback function. That's really all we need to do in here, is just actually make a remove call. So that gets passed in the file path, the stat structure, type flag, and ftw structure. Alright, and this will be simple enough. We're just going to say remove that path. If there was a failure there, just do a p error. And return the RV. And that should be it for it. Let's do another build now. Alright, let's see. First main, yeah, actually we want to replace this function. Package build, we'll just get rid of that because we have our own implementation in build.c now. So make clean, make and okay, I need to add a header for remove directory and probably for package build as well. So let's go back to our common.c. Now what do int remove directory, char pointer path, and for the package build, that's not where we want to add it really. Alright, let's go into main.c or package.h. Alright, let's find, where is it at in here? Package build. Just copy this. Yeah, I'm just going to put it in main.c right above package install as a declaration. So clear. Let's make that. Everything looks good. Now we can, yeah, okay, so spkm is there. So let's see, spkm root. So let's cat spkm root user share spkm repo. Yeah, tab messes this up. Repo glibc, and we'll say .pck. Okay, yeah, we see it's in there. And the build file. Just double checking to make sure those files existed. So now let's clear and spkm. Now I have my spkm root set in this console, so if you don't have it set, you want to pass it in with the -r command. So mine is already set in the environment, so I'm just going to use not -i-b to build, and then I guess just the file name glibc. And let's see, failed to download. No such file directory, and that's because I'm missing something here. So let's make directory spkm root user share spkm dl-cache. That file did not exist, or that path didn't exist. You need to use sudo to create it. Let's run that, and we have a permission denied. That's because we need to run spkm as sudo. And invalid glibc. That's because sudo doesn't automatically take in your environment variables. So you need to run sudo -e, capital E. There you go. Now it's downloading the source. Now it should be downloading the extras. Looks like there's some failures trying to download the extras. Okay, so it failed to download the TZ data. Alright, I did a little research. I'm adding to our download file in our download.c user agent, and this string here, Mozilla compatible MSIE. It looks like sometimes the URLs don't like you using code to download things, so we're kind of faking it so that our code looks like it's coming from Firefox or IE or something. So now let's rebuild it. Sudo -e spkm -b glibc, and the build file exists. Let me remove that. Alright, run it again. And so now it failed to download one of the patch files, and that is, let me add some extra handling because it should have found that patch file correctly. We did copy it, so let's make sure we change to the correct base. I'm going to just add a printf changed into build base. And source base, we have that there. Else we'll printf no source base, staying in build base. And let's debug this find source path as well. Maybe add some debug output. So we're opening directory build base, creating that source path. We should probably print that out. And then with the source path, print it out before we return it to make sure that we're turning the right value. Oh, actually, you know what? It looks like we're not returning it. That's our problem. See, a warning for that would have been nice, but it doesn't warn if you don't return from a value that expects a return. Alright, let me start this back over. I'm going to first clear that old build path, make it again, and run this one more time. Alright, now you can see it's already started running. So, yep, everything looks like it's building properly. Make this a little bigger. I'm just going to quickly fast forward to this whole build process because in this VM it's going to take like probably 15 minutes to run this whole build for glibc because it's a pretty big one. So you now see its packaging is complete. Removed our build directory. It does say package installed, but we didn't install. Let me just look, where are we printing out that package install? Yeah, it should be down here in the main. So we have our build and then package. Yeah, I think we just don't want it to print out package installed unless they had the install option and did the install. So I'll just cut this and put it up here. Alright, so that should be all that we need to run our building of packages. So this should work with all of the packages you want to build, but before we get too heavily into building all the packages, we want to actually install as well, because anything that you build after this is going to expect glibc to be installed in your environment as well. So you can see where I created our glibc under our build path there. Don't want to open it. What I can do is just copy this in tar-tf so we can see the contents. Okay, it's a lot of files, as expected. Let me just use some more. Okay, we have the files in sbin, the files in lib. You could loop through here just to look and see that all your files are there. I'm just gonna check. Let me just grep for install. Okay, yeah, there's our .install files. They're correctly added to the package as well. So I think that should be it for our build process. Like I said, we still need to run an installer before we get too deep into building packages, because the next packages that we build are going to expect this version of glibc to be the version that's installed in our build environment. So we'll do that in the next video. And I hope you enjoyed this video and learned something from it. Again, I know it's covering kind of a lot, and I was kind of breezing through it because it's already kind of over 45 minutes for just the building process. So again, if you enjoyed this video, like, comment, subscribe, and all that. Join our Discord server, and ask any questions or comments there as well. And thanks again for watching.